Meet install, the GNU coreutils workhorse that does two jobs in one shot. It copies files into place and sets their permissions and ownership. That single-step combination is why makefiles, packaging scripts, and build systems reach for it constantly. One command, one atomic operation, no follow-up chmod needed. Compare CP and install side by side. CP script.shrun.sh just dumps the bits. The new file inherits your mask and lands non-executable. To make it runnable, you need a second command. Chmod 755 run.sh. That's two file system events, two chances for something to go wrong. Install m755 script.shrun.sh does both in one atomic operation. Copy set mode done. No race window, no forgotten chmod. For directories, install D is the packaging-friendly cousin of mkdir. Both create nested directory trees like /package/bin and /package/ etc. in one call. But install D plays nicely with dest or four-staged installs and silently succeeds on directories that already exist. No error noise cluttering your build log. When you're scripting package creation, that idempotent behavior is gold. The M mode flag is where install earns its keep. Modes are written in octal. 755 for executables, 644 for regular files, 4755 for Setuid binaries. The critical advantage. Explicit modes override whatever a mask the build user happens to have. Run the makefile as a paranoid user with the mask 077, and your executables still land with mode 755, because install sets the bits directly, not through the kernel's default permission path. The O owner and G group flags lock down who owns the file. During package staging, root build scripts use install, O root, G root to guarantee the installed files are owned by root regardless of who actually ran the build. This step requires root privileges. Non-root users get a permission denied, but it's exactly what you want when assembling a tarball that will deploy as a system package. 3 more flags round out the toolkit. S strips debugging symbols from binaries, shrinking release builds automatically. No need for a separate strip pass. T directory copies files into an existing target directory, great for batch installs. And V prints verbose output so you can see exactly which file went where when debugging a flaky makefile. In the real world, 3 big ecosystems lean on install hard. Debian's _install uses it to drop files into deb package staging directories. AutoTools makefile install targets default to install. M commands for every binary and man page. Arch Linux pkgbuild files rely on it for the entire package function. The reason is simple. Install collapses CP, chmod, and chown into one reliable, mask-proof command, and reproducibility is everything in package building. Welcome to this terminal walkthrough. We'll explore the GNU install command, a powerful alternative to CP that copies files, sets permissions, and creates directories in a single step. It's a staple in makefiles, packaging scripts, and system administration. We start by clearing the screen with clear to give us a clean workspace. This is a standard habit before any terminal demonstration. The command is typed at the prompt, ready to execute. Next, we move into the temporary directory and create a fresh working folder called install-demo. Using and chains the commands so we end up inside the new directory in one shot. Notice the prompt now reflects our new location. We create a simple source file named script.sh containing the word demo. This gives us something to copy in the next step. The redirect operator writes the text directly into the file without any output to the screen. Now we use install m755 to copy script.sh to our un.sh while setting executable permissions in one atomic step. The 755 mode grants read-write execute to the owner and read execute to group and others. This is far cleaner than chaining CP and chmod separately. The install D flag creates directories similar to mkdir, but integrated into the install toolset. Here we create bin and etc. subdirectories in one command. Both directories are created silently with no output, and any necessary parents are handled automatically. Let's verify the results with ls/la. We can see our un.sh has the rwxrxrx permissions we set with m755, and the bin and etc. directories are listed with proper ownership. The script.sh source file is also still present. Finally, we confirm which version of install we have on the system. The version flag prints the coreutils version banner, and piping to head keeps the output tidy. This is a good habit for verifying your environment before relying on any tool's behavior.